All right, so here we are. It is week 11. ETEC 214, energy storage and distribution. We're doing electric vehicles this week. And I just got back from California. I saw a lot of Teslas, mostly in the northern part of the state. Silicon Valley area, you get down south, a lot more combustion engines. But I got a few little pictures, some other little cute little rinky-dink EVs. They're coming, as is the level 5 fully autonomous Tesla.
I know, isn't it a sexy car?
It's coming. Glenn Kreisel right here in town is going to get one, and we're all going to go joyriding.
Yes, we are.
It's going to be great. You know what? You're not kidding. The internet's slow, huh?
Slow down, slow today. Stay off it as much as possible. Or get logged on and don't get on.
It's just our local server here.
It has its days. That's for sure.
EVs. Okay, so we've done problems up to week 10. Get myself into the website. Dive into 11. Electric vehicles. A lot of Priuses too. I walked into the San Diego airport. All the taxis are Priuses, every single one of them. Oh, and LAPD, NYPD, going electric. Electric
The
fleet.
PD's not got highway patrols.
Yeah, probably just PDs. I just heard that their fleets are going electric. That's big.
Oh, because they're in-town based and stuff.
Yeah. If you need a
There,
quick
you go from here to
swap it
there.
out, charge me out. Yeah. Come on. Okay, we've entered the matrix. Was it the red pill or the blue pill? I can't remember. Blue? It's blue in and red's out.
What's wrong with red? Everybody's afraid of red.
Somebody was. Ooh, man, God, I thought we were going to get in there. Traffic jam in cyberspace. All right, EVs are back. Now, if you remember before, we did the problem to kind of pencil it out whether or not you could run your refrigerator for a week on your Prius or not. Looks like you could.
And your water pump too.
Water pump, yeah. Vehicle to grid idea. And another thing, one other bit of news. When I was riding home from work on Tuesday, I called Al Frazier just because, also very worth noting for the record. We were kicking around the problem set. There's true power, apparent power, reactive power, and you're also going to get dinged by the utility if you have a demand load. So if your kilowatts go way up, you'll also get dinged if your reactive power is high or your power factor is low. But it's not on an hourly basis. So there were two solutions. So Warner had a solution and Froelich had a solution. Froelich's was more because he multiplied his reactive power charge by the number of hours, which was incorrect. Intuitive, but wrong.
So the reactive power is the kilovolt amps, and then the apparent power is the kilowatts. True power is kilowatts, apparent power is kVA, and reactive power is kVAR?
Yep, you got it. But then Frazier went on to say, did you hear about what happened in California last week? No. The price of electricity went negative. It's deregulated, so like you're trying to sell your electricity. Well, sorry, we don't want it, it's too much. You have to pay to get rid of it.
Solar, because the governor made everybody go solar. And now they have too much, that makes sense.
That's why we need storage. And that's why your electric car is gonna be your, so if you don't want it here, I'll take it over here, you know? Yeah, it's your bank, it's your electron piggy
I wonder if
bank.
my outlaws have power on right now then.
You know?
They've had solar since the 70s.
Yeah. So this is key. Of course, if you correctly apply the national electric code, you would need a transfer switch to isolate the microgrid from the grid system. We know why that is, because if the power goes out, you don't want to be live and then the poor utility guy gets zapped because your Prius is blasting still. That's the reason right there.
Oh, you want to be nice?
Well, you want to be safe. You want to protect your fellow man. Okay, so here's some old school EVs. Not a new concept. Essentially been around as long as batteries have been. And of course, as battery technology, and perhaps even more importantly, battery management technology improves, these are only going to get better.
Big one.
Okay. Assignment. Problem 1. You have been asked to design a graph that will answer your customer's questions about how long it will take to recharge an EV. Develop a graph for table plotting miles against charge time. Let's see here, okay. X-axis is 0 to 100, y-axis is in hours. People always ask me, my question is how many miles are, okay. For now, without considering the Tesla, because out of my price range, there are 2 basic methods to recharge. At home, 2, okay. EVs have different efficiencies like gas cars, and this time we last assume 3.5 miles per kilowatt hour. Okay. Based on miles traveled. If you don't figure out how to create a graphic, so. Oh, okay. Let's check it out. So here's one thing. We're just going to take this text. We'll just start fresh. Microsoft Excel. I should have started that a while ago, shouldn't I?
Mine's going a little bit faster than yours.
This is new. Normally this machine is just cooking right along.
Well, it must be the high school kids are out today or something.
Yeah, that's it.
Tell you, when they're not in school, you might as well not get on the internet.
You think the Sentinel kids are sucking on our Wi-Fi?
Probably.
Maybe.
I would guarantee it.
Text box. Yes, please. Yeah, so this is a nice little practice. You know, put that in your spreadsheet. 12-point font. If you're getting old like me, make it bigger. Well, you know.
My eye doctor already threatened bifocals, and now I'm finding myself zooming in on everything.
Oh. So I'm also going to show just how easy it is to make a plot in Excel. I know you've seen this before, but let's just say here's X. Let's see, here's Y. Let's say here's 0, here's 1. I'm going to take this now and I put in 0, 1. I'm going to drag it. I'm going to say this equals X squared, 0 times 0. Enter, drag it. Boom, boom, grab the whole thing. Insert, charts, done. So I made a chart in Excel in
Are you
20 seconds.
recording this?
Yeah.
Okay. And you're gonna post it?
That's, yeah, every week. So, we just made a graph in Excel in
Seconds.
seconds.
Right.
It's good, it's fast, it's easy. And just as quickly, we can make it go away. All right, so now we've got everything we want it, where we want it. Everything right where we want it. Okay. X-axis is 0 to 100 miles. That's easy also. And we'll call it distance. That's what it is. Or let's call it range. Range. And we'll put our units in miles. And here's 0. Here's 10. And we'll grab those two guys. You have to grab the first two, run it down, stop at 100. Boom. Yeah, there's your range. Using this graph, a person can determine how long the charging time to make it. So like, okay, the question is, I gotta go 20 miles, how long do I have to plug in if I'm on empty? Two basic methods. So one is $1.20 at 12.5. So let's just highlight that. Hello, hello.
Wrong highlighting point. Need my eyes just
That's bad. Actually, no, I don't need a color. I want a bigger, let's just underline it. How about that?
There you go.
112 volts and that many amps. So level 1, and we have volts, 120, we have amps, 12.5, okay. And 93% power factor. 0.93. And we'll put that as a percentage. Let's leave it like this. All right. Level 2. Level 240 volts, 240 amps, 29.5 power factor, 93. Okay. Underline bold. Underline bold. Underline bold. If someone wants to use a Tesla charger, it's too bad. Okay. For this assignment, let's say, so 3.5 miles per kilowatt hour. This is going to be mileage in, this is, what is it, miles per kilowatt hour, right? Miles per kilowatt hour. So, it's miles per gallon, except it's, instead of gallons of fuel, we're using kilowatt hours of electricity. Come back, so 3.5, we're using that. Bold, underline. Okay. Create a graph or table with a line for each charging level and how long it will take based on miles traveled. Okay. So let's. So I think the thing to do is we want to figure out kilowatt hours per hour. Let's get the pen going here.
Yeah.
Power of the pen. You got to start with a picture. Okay.
Hold it the right way.
So let's think of it this way. So here's our time, and here are our kilowatt hours. And we know that, so level 1 is going to be something like this, and level 2 is going to be something like this. Right, so, and this is, and again, we go right back, energy equals power times time, right back there. So,
It was energy, power divided by time, or it was force times distance. Right? Force, mass acceleration, and then energy is force times distance, and then power is energy over time.
yep, you got it.
Because energy can be power over time too.
What's that?
Energy can be power over time too.
Not in this universe.
Not in this universe?
No.
So that's inaccurate?
Energy is power times time.
Oh, okay.
Energy is the product of power and time. Yep. Yep.
It's work.
Yeah, okay, so, and we know that, we know that power equals volts times amps. Now, how to deal with that power factor, though? Because I think what might be going on here is, because your battery's down here. Here's your car battery sitting down here. And this is, it's a resistor. This is your meter up here, though. All right, so this is power, and this is apparent power. And I believe, if I'm not mistaken, power equals apparent power times power factor. Right? I think that's the way it works. So let's just put it like this: PQ. That's apparent power. All right. So energy will work like this. I think the energy in kilowatt hours is going to equal the it's going to equal Q times the power factor, PF times time, equals volts times amps times power factor times time. Right? Yeah. So so we know this. So let's go ahead and bang that out really quick. Let's do it like so. So energy. Well, we got to take it one step further. Let's just nail it.
Good.
Yeah, because what do we call this, range?
In miles?
Yeah, range equals energy in kilowatt hours times the mileage.
Okay.
What's a good symbol for mileage?
And
Yeah, it's like mile, what's a good symbol for mileage? We'll just call it what it is. It's miles per kilowatt hour. That's what it is. So let's call it this. Equals E in kilowatt hours times MPKW. Like we normally use like MPG, so let's just call it MPKW.
Okay.
Yeah, right, okay. Now we've got two equations. What we're actually trying to solve for is time. So let's take this guy. So we've got EKWH equals R over MPKW, right? Now let's take it back up here. R over MPKW, a little clunky, but too bad, equals V times A times power factor times time. Whew! Now, I'm going to take this whole guy right over here. Time equals range, which we have. That's our independent variable. That's what we're going to give it. We're going to give it how far we're going to go, divided by V, A, PF, MPKW. Right, so what we did, we just took that, and that. We took those three guys and shoved them in the denominator on the other side. So this is our equation.
Easy.
Yeah, and that way you're not dinking around all that guy. Okay, that's the power of the pen right there. And is everything in the proper units? Kilowatts? I think we're going to have to go. We might have to go.
Because you got, because we're trying to find the time.
Yeah, because these guys are going to be in. Yeah, these are going to be in watts, not kilowatts. So let's do that right now.
So we need a conversion of watts to kilowatts.
Exactly. Yep.
What was the R again?
Range.
It's your, mileage.
It's your distance. R is your distance.
And then the miles per kilowatt hour with MPKW?
Yeah, MPKW. I just call it instead of MPG,
Right.
MPKW. Okay, and this will be our power.
Velocity and then A is what? So,
A is amperage. Yeah. I probably should have used I, but I used A instead. I'm sorry. Power in watts equals dink times dink. And actually, this is going to be power. This is actually apparent power. That's good. Apparent power. PQRPR. That's fine. I'll just call P sub A as apparent power, and this will be copy, paste. This will be apparent power in kilowatts. Okay, so now we have everything in kilowatts equals dink over 1,000.
Oh, we need this thing here.
I think now watch this. I'm just going to take these two guys, copy them, and paste it. Thank you, Bill Gates. Wow, that is ripping right there. 7 kilowatts? Yowza! future is here.
Right?
Yeah. All right, now, this is gonna be, time, level 1. Subscript, center, copy, paste, time, level 2. All right, so now it's plug and chug. Equals the range divided by volts times amps. Well, we already did that. Volts times amps, right there. This is volts times amps, that's the apparent power, divided by, we're still in the denominator, power factor 1, which is right there. So we lost a little bit from power factor because it's less than unity. That's moving in the right direction. Divided by the mileage, which I will put there, I promise. 3.5. 3.5. Now, if I go up here, I'm going to want to pin these. C25.
Oh, okay.
Pin that guy. Pin that guy. All right. Now I can drag her. And let's... And we'll do this guy also in hours. Fontsky. Kiski. Okay. Okay. And then I'm going to here's kind of the quick and dirty copy, paste. We know it's wrong. Fine. We know where to find the right answers though. You go there. You go there, oops, there, and you go there. Yeah. Wow, it's so much faster, huh? So much, well, it's a lot of juice.
Hold on, just 1 second, I gotta get the VAPF Let's see.
All right, so here we are, we're looking at it. There's our range. There's our charge time. Now we can just go back and insert. Chartola. Yeah. Charge time. On this thing too, it's always good, make that font a little bit bigger. What to? Text options, I think should be a way to labels, number. Let's knock a decimal place off of that. And I'm thinking here also, there's so little resolution there. You might consider just let's see what happens if we put this on the secondary axis. And then, so it charges in less than an hour. And, well, I don't know, what do you think?
Members of the neighborhood.
What's that? What'd you get?
Well, for the time one, I got 0, 1.5, 2.9. Will you click on there so I can see who you click?
Yeah. So I multiply, I've got the range, and then I divided by power factor, and mileage.
So how did you get all three L1? So I got a chart title, but I only have one line. I guess I have to edit.
Do you have both data sets in?
Select data and then
Well,
you have to add
you can add another one, yeah, for sure.
this one. And then this one. And
There's always a little risk in messing with this, isn't there? I don't know.
they made it separate.
Okay, so let's say you just first did just this and said, insert chart. There it is. You're like, oh no, I need more data. Right click, select data, watching, add, series name,
You just select it.
boom, boom. X values, boom, boom. Y values, boom, boom. Okay, okay.
Wow, no difference.
So I guess my point here that I'm trying to make is you couldn't really read the other line because it's so low. So what I've tried to do with this guy is, where's that orange? Maybe it's that one. Like that, make it bigger, make it bold. If you want to get fancy, you could turn that into hours and minutes. I'm sure there's a way to format it in Excel. Down here, let's make this a little bit bigger. Let's make it bold. Take it like this. We're going to copy the whole thing. Go Pro. Here comes PowerPoint. All right, here's your deal. Select all, delete, home, paste, picture, charge time, level 2, and then you can come in. I'd take this and crop off the outside, crop off the outside. You did some nice graphing in you went the extra mile and graphed a little bit in one of your problems, just didn't you? Love it. Then insert.
Well, you can style your whole.
Yeah.
thing. You can get way fancy.
But to get here though, this is gonna be mileage in miles. And over here, copy paste. Let's take this guy. Blue. Let's go blue. Charge time in hours. Rotate it. Woo! Yippee! And and label it to level 1. Copy paste. Level 2. Keep your colors consistent. And then then that label at the top becomes superfluous, just lop it off of there.
The range is the Y or is the X? I'm still on that, so
Save.
it's the
Okay, that problem's a wrap. Should we keep going? Yeah, let's keep going.